Well, happy Tuesday. It's twin day. Well, for me. Start on it anyways. This is the Unit 5 twin. And let's do bonuses first. Find the domain of the composite function f composed of g when f of x is 10 divided by x plus 10 and g of x is 10 over x. So there's some rules about domain. There's only two of them, actually. For the square root of something, whatever it is, the something must be greater than or equal to 0, because the smallest thing you can take the square root of is 0. And the other deal is if you have 1 over, I don't know, let's use a frowny face this time. The frowny face cannot be 0. Those are the only two rules about domain. That's it. So we're doing what's called a composition function. This is f composed of g, better known as f of g of x. And what that means is every x in f of x becomes g of x, which is 10 over x. There's the deal right there. All right. Now, the first thing I notice is when I look at g is that x cannot be 0. Composition functions, domain is inherited from the seed. That's kind of the other issue. Domain is inherited, which I'm pretty sure I misspelled, from the seed. And we are literally seeding f with g of x. So let's make our composition function. F composed of g of x would be initially 10 over x plus 10. And I can look right here and tell you that x is not 0. If x is 0, this thing is dead in the water. And what we have to do is here we have to clean up the fraction to get it in a more appropriate form, and we might see something else, because there is something else. All right. Now, this is what's called a nested fraction. And what I'm going to do is I'm going to x every single piece. As long as you multiply everything by an x, you don't change it. And I'm left with 10x over 10 plus 10x. Okay, so here's the other deal. 10 plus 10x cannot be 0, because I cannot divide by 0. So 10x cannot be negative 10, and x cannot be negative 1. So there's my two things I can't be. You start putting those things on a number line, and you can be everything to the left of negative 1. You can be the space in between, and you can be all this. So we write this out as an interval, negative infinity to negative 1, unioned with 0 to infinity. That's first bonus. All right, divide x to the fourth plus 625 by x minus 5, which I have a hunch is a factor. I'll just do it with synthetic division. X minus 5 is 0, x is 5. Placeholders 1, 0. I need something for the cubed, the squared, and the x. This is cubed, squared, x, 625. Fourth, third, second, x. All right, cool. And you know what to do from there, right? So that was your hint. This is just more than a hint. Synthetically divide. Compute the discriminant. Then determine the number and type of solutions for the equation 6x squared minus 8x minus 7. First thing is to one-side this thing. And the discriminant is the b squared minus 4ac piece. All right? I don't know that you have to compute the discriminant. You can always just do the quadratic formula. It would tell you exactly what's going on anyways. But the deal with the discriminant is if you're equal to 0, there is one real repeated solution. If b squared minus 4ac is less than 0, there are two non-real, also known as imaginary, solutions, which are conjugates of each other. And if b squared minus 4ac is greater than 0, there are two real, unique or distinct, who knows how it's going to get worded, but there's two real solutions. And that's the hint on 19. I'll let you figure out the discriminant. solve the system of equations. This can be done in a graphing calculator, but it's not quite as easy as you might want it to be. It's actually not too hard to do by hand. We're just going to take x minus 3 and we're going to divide it by 2 because that would make it y. It's called substitution. So everywhere I see a y, I get to be x minus 3 over 2. So I'm going to plug in right here where my ink pen is, and I'm going to replace that with x minus 3 over 2. And this is going to enable me to solve for x. Now, I'll even show you what the x value is. I mean, if I distribute negative x squared minus 3x, both pieces over that 2, by the way. I do not like the fact that I'm dividing by 2, so I'm going to double every single thing. 2x squared minus, the 2's cancel there. X squared, need parentheses, minus 3x. Because I'm going to take away 2 things, not 1, equal to 40. 2x squared minus x squared plus 3x is 40. And we'll have x squared plus 3x minus 40 is 0, which is something you ought to be able to factor. No? I don't know. You'd have x plus 8, and then what? X minus 5 is 0. So your x values are going to be 8 and 5. And then you plug these in to get y values. You're actually going to have 2 sets of ordered pairs. You know, you plug in this 8, you get a y value. You plug in this 5 up here, you get a y value. So you're going to have 2 sets of ordered pairs. All right, that's how you do 20. 29, solve the rational inequality. Express the solution set in interval notation. These aren't as bad as kids like I think they are. I don't teach this in Algebra 2 because, you know, the mastery rate would be like 5%. But the reason kids don't like this is because it's done with a visual aspect. That's the whole reason. It's done with a visual aspect. You could also look at the graph, by the way, which I might do. But even then, a lot of kids don't figure it out. What I do is I pick out what's called critical points. There's 3 of them. There's one here, one there, one there. There's 3 critical points. There's x equals negative 10, there's x equals 8, and there's x equals 1. Now, by the way, the 1 is something x cannot be, because that's a domain issue that would cause division of 0. So when I put a circle at 1, I'm going to, you know, put an open hole there. Negative 10 just be somewhere back here. It can be negative 10. There's an equal symbol. There's nothing wrong with that. And then there's 8, which can also be something you can be. And we're just going to test. You know, I'm going to test a negative 11. I'm going to test something between, which is 0. And I'm going to test something between, which is 2. That's all I'm going to do. So if I test a negative 11, I would have negative 11 plus 10, negative 11 minus 8, over negative 11 minus 1. And negative 11 plus 10 is negative 1. This is negative, what, 19? And it's going to be divided by a negative 12. So I'm going to have 19 over a negative 12. And that's false, because that is definitely less than or equal to 0. So this is false. So nothing over there. I'm not keeping anything to the left. If I test a 0, I would have 0 plus 10, 0 minus 8, 0 minus 1. This is going to be a winner, because this is negative 80 over negative 1, which is 80, which is true, because that is bigger than 0. So all of this is true. And then I'm going to test a 2. If I test a 2, it's probably going to be false. 2 plus 10, 2 minus 8, 2 minus 1. That's going to be 12 times negative 6, which is negative 72, and it's sitting over 1. So this is bleh. Oh, I also have to test something else like a 9. I got to test to the right of 8. Now, if I do a 9, I'm going to have 19, and I'm going to have 1, and I'm going to have 8 in the bottom. Well, this is true too. That's bigger than 0. So I get to be that. So the space I get to be is between -10 and 1, unioned with 8 to infinity. And notice the brackets and the parentheses, all that stuff still matters. I did mention you could do this in a TI-84. You can. It's maybe not as obvious as what's going on. So I'm going to math, number, down to numerator over denominator. It's the easiest way to type this in. That gives you the fractions, which is a big deal because a lot of kids never figure out how to wrap things properly in and outside of a math class. And this is not a color addition, but you put a 0 there. And even then, it doesn't matter. It's about where are we more than 0. We're more than 0 from here and from here. And the issue with the calculator is it doesn't tell you where you're not. We're going to kind of have to look up a lot. I said it could be done in a calculator. I didn't say it'd be easy. Yeah, see, the calculator doesn't really give you the hint here that it's stopping at 1. It kind of looks like it's stopping close to 0. Maybe it's going past there. So by hand is still winning. I hate it for you. You could probably look at the table. Table will tell you something. So there's 10, which is 0. At -11, you're less than 0. And if you look at the table, from -10 all the way to very close to 1, 1's an error. So you can kind of look at the table and come up with it too. All right, solve this equation. 32 to the x is 1 over root 2. Lots of ways of doing this. Lots and lots of ways of doing this. So let's teach you ahead of time. We have this. Here's an idea that's coming in after Christmas. A logarithm base b, argument a equal to sum e has an equivalent inverse in the form base to the exponent equal to a. So this is 32 to the x, and it's equal to 1 over the root 2. So this is my base. This would be the base's exponent. And what's left, if you look at the notation I'm using, or the form I'm using here, this is my argument. You know, that's probably not the best way to do this one for y'all. I'm going to use a technique called ln both sides. All right. You're probably like, what's ln? Well, just look at your calculator. It stands for natural log. The natural log of 32 to the x is equal to the natural log of 1 over a root of 2. There is a property in logarithms which a lot of the honors kids know. It says log a to the r is r log a. And a natural log is a logarithm. And it's saying you can take these exponents and you can move them out front. So x natural logs of 32 is equal to the natural log of 1 over root 2. And then what we do is we divide by the natural log of 32. I need to pause this real quick and take a look at the original document. Actually, I'm not even going to pause it. I just want to see how the answers are presented. I want to see if there's some manipulation of the logarithm. No, they just have a straight up answer. So that's cool. At this point in time, you can go to your calculator. Then you can just type it in. You got the natural log of 1 divided by a root of 2. And it is divided by the natural log of 32. And you can't see what I'm doing, can you? I just typed in what I wrote on paper. And I press the enter key and I get -0.1, so -1 over 10. All right, solve this equation. 4 to the x plus 4 is 5 to the 2x plus 5. And I'm going to use the same technique as I did on the last one. I'm going to take the natural log of both sides. So the natural log of 4 to the x plus 4 is the natural log of 5 to the 2x plus 5. I know it seems kind of funny that I introduced this ln both sides. Math is about balance. As long as you do the same thing to each side of the equation, you didn't change anything. You know, I say stupid things like if you flip off one side, you better flip off the other. That's because that's fair. That's what equality is about. And that's what math is about. Just do the same thing to both sides. So using the property from up here, I can move this x plus 4, which is two things, so I'm going to wrap, in front of the natural log of 4. And I can move this 2x plus 5, which is two things, so I'm going to wrap, in front of the natural log of 5. And then I get to use what's called the distributive property. And I know that just the fact that we're talking about a natural log just throws kids off, but you know, whatever. I would have x natural logs of 4 plus 4 natural logs of 4 equal to 2x natural logs of 5 plus 5 natural logs of 5. And what I'm going to do is I'm going to get my x's on one side and my numbers on the other. That's it. X natural logs of 4 minus 2x natural logs of 5, because those are x's, they contain x's, is 5 natural logs of 5 minus 4 natural logs of 4. And first commandment in math is if you can pull it, pull it. I can pull an x from both pieces. So x times the natural log of 4 minus 2 natural logs of 5 is 5 natural logs of 5 minus 4 natural logs of 4. There's an understood multiplier symbol in here, and I know this looks so funky. Just focus on basics. The opposite of multiplication is division. So x is 5 natural logs of 5 minus 4 natural logs of 4, sitting over the natural log of 4 minus 2 natural logs of 5. That's probably how the answer is presented. If you want the decimal, you just type the thing in. There is an ln key, by the way. I didn't point that out a minute ago. It's right there. It's where she is. So I just typed it in like I wrote it. And there's the decimal, negative 1.3653. But I'm pretty sure this would be given an exact form. I always take logarithms to the fourth decimal around it. And the last bonus, write the equation in STD form, then give the center and radius of the circle. This is done by completing the square twice. You complete the square twice. What we do is we group our x's, and this, by the way, is a geometry standard. I don't know if you were taught it last year, but it is a geometry standard. So we group the x's, and then we group the y's, and we'll just leave that constant over there on the right. And what we're going to do is we're going to complete the square here. I take half of 6 and I get a 3. I square the 3 and I get a 9. So I add 9 here, and for balance purposes, I add 9 there. Now I'm going to take half the 4. I get a 2. I square said 2, I get a 4, and I add it to both sides. So this is a perfect square. Factors is x plus 3 times x plus 3, or x plus 3 squared. This is also a perfect square. Factors is y plus 2 squared. And the right-hand side, what's it add up to? 16? So why did I make it look like that? Because I forgot to mention something you're supposed to already know. The STD form of a circle is x minus h squared plus y minus k squared equal to r squared. So where hk is the center. And it wants the center and radius of the circle, so negative 3, negative 2. Center is at negative 3, negative 2. And there's a line up here between r squared and 16, so r squared is 16. So my radius is 4. And there's your bonus questions. I even did most of them. Hope you learned something. That's the goal of this. Oh, by the way, it will, the reason I cut off all the choices here is so there was a lot of kids who got bonuses on the last one because some of the smarter kids who figured them out gave away answers. You should not give stuff away. You shouldn't take money for it either. What you're doing is immoral. Sharing answers is not something you should do. It's really not.